Well, stay there. Stay there. What is the expression for 3x to the power negative 1? It's what? It's 3 times 1 over x, right? Plus 3 times 1 over y, yes? How about here? This is what? 1 over x squared. And then minus 1 over y squared. Many people got this wrong. If you do this, on the exam, I will have double points deducted. Okay, now let me repeat so that you know that I said it. On the exam, if you do this, because this is like the second time, the third time that we do this, you really need to know what do you mean by this, okay? This negative 1 power only apply to x, not apply to 3. If you do this on your exam, you will get double points deducted. Is that okay? Don't forget, okay? Try to mark it on your notes. All right, now what's next? It is what? 3 over x plus 3 over y over 1 over x squared minus 1 over y squared. How do you simplify it? Would you like to multiply both by the LCD? Okay. It doesn't matter. You need to know both, right? What is the LCD right now? X squared, y squared. Now you need to multiply every term by that, right? If you multiply this by x squared, y squared, x goes into here. So you have 3 times xy. Am I too fast? Yes? Okay, then I will stop here. You tell me which part you don't know. 3 over x times x squared, y squared. Your x goes into x squared, you have x there. So you get 3xy squared, right? The second term, 3 over y times x squared, y squared. The y go into y squared, you still have y, so you have 3x squared y. Yes? All right? So for the denominator, you have 1 over x squared, so I will write it out. Minus 1 over y squared times x squared, y squared. So here and there. So the answer will be 3xy squared plus 3x squared y over y squared minus x squared. Is what? This is a method 2. Then you multiply else. Yeah, we will. Okay. All right. So now everybody look at this and say, hey, do they have common factor? Which is 3xy. So now you have 3xy times y plus x, right? Can you factor this? Which is y minus x times y plus x. Wow. Why we need to factor? Because we want to see whether we can simplify, right? Can I simplify?
Yes. Y.
Yes, right? Y plus x and y plus x are common factor. So you can divide it out. So what is the answer? 3xy over and y minus x. Did you get this? If you get this, then it's good. Yeah? If you do the long division, you still need to get this one. How many of you do the long division? Raise your hand. You like the long division. How many of you do the LCD? Okay. How many of you do both? Yay! Only me. Okay, how do you do that long division? Well, do I need to do the long division? Try both. Okay, let me write it here. So you have 3 over x plus 3 over y divided by 1 over x squared minus 1 over y squared. Is that okay? Okay. Then you will have, you multiply y, here multiply x. Am I correct? So you get 3y plus 3x over xy. Divided by what? Now here, times y squared here, you times x squared times x squared. Yeah? Okay? So what do you have? You have y squared minus x squared, and the denominator is y squared x squared. Yeah? Did you get that? Now, it becomes 3 of y plus x over xy times its reciprocal. And here you have difference of squares, so you can factor. See, now you have this divide out. Now you have this divide out. So the answer will be 3xy over y minus x. They are the same. People have different, it's okay. As long as you know, you need to know both. How many of you got this right? How many of you got this right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. How do you do number 41? Well, can you tell me what is that? That is 1 over m plus n. And this is 1 over m plus 1 over n. Would you like to do with a division? Or would you like to multiply LCD? All right, if you like to multiply LCD, what is LCD now? It's m plus n times m times n. All right. So times m plus n times m times n. Times m plus n times m times n. Is that right? Okay, so when you multiply the numerator, what do you get? M times n. Yeah? How about the denominator? We need to what? Distribute. Am I correct? Yes or no? Yes. So what do you get? When you have this multiply that, you have m plus n times n over m. Yes? Plus m plus n times n over n. Am I too fast for you guys? Yes? Where is fast? You don't know this? You don't know the distribute property? Do you know? 1 over m times this. This is this over 1, right? Yes or no? 1 over m times this over 1. Don't you get this? Yes. So now m and m will be divided out. 1 over n times this LCD, you get m plus n times n over n. And n will be common factor to be divided out, right? So now what is the result? The numerator is m times n. How about the denominator? M plus n times n. This is this term. Plus, what is this? M plus n times m. Do you see that? And these two terms, do they have common factor? Do they? What is a common factor? M plus n. So you will have m plus n times m plus m. Right? This is common. Factor it out. Ah, are they the same? So what do you say? You say, hey, This is just m times n over m plus n squared. How many of you got this answer? Yay! Is this okay? Okay. Uh-huh. Okay.
Why is that a 1 right there?
It's because, you mean for this one?
Down here, where it goes from b squared.
Because this is 1 times b.
Yeah.
Okay? You both have b squared.
Yeah.
You factor it out, you still have 1. So 1 minus this. It's just like this. If you have xy minus xz, right? You factor out x
times
y minus z, right?
Yeah.
But how about if I have x minus xz? Then you factor out x, and then what?
1 minus z.
1 minus z.
Okay, I'm just confused because this is b squared minus b, and that's b squared times 1 minus b.
It's b squared, b squared. Okay, now.
I have a question.
Yes?
Where did the n and the m go?
Hello? Where?
Right? No, right that, yeah, right those.
Oh, this is a very, very, very important question, okay? I need all of your attention. How many terms in the denominator? 2. The first term is m plus n times n. The second term is m plus n times m. So for these two terms, they have common factor m plus n, right? It's just like this. If you have x times y plus x times z, for these two terms, they have x as a common factor. You factor it out, then you have y times y plus z, yeah? Now this is common. So I factor it out times n plus m. It's distributive property. You use it reversely. You have to put m plus n parentheses squared. Yeah, because they are the same. All right. Understand? Okay, we have talked about what is a to the power 1/2. What is a to the power 1/2? It is what? Square root of a. What is a to the power 1/3? It's cube root of a. What is a to the power 1/5? It will be fifth root of a, right? So you have known this for a while. Now we need to learn more. What do you mean by a to the power general fraction m over n? Okay? So you see the n, the denominator will be your nth root, right? That's your index. The numerator is going to be your power. Okay? Let's see what does it mean. Okay. When you say square root of a and nth root of a is b, that means a is b to the power n. For example, what is the square root of 121? 11. Why? Because 11 squared is 121, right? Now you tell me, what is the cube root of negative 1,000? Answer this. Okay, listen. What is 3? Is even or odd? Odd. So you're trying to find a number that you multiply 3 times and you get negative 1,000. So that number has to be positive or negative? Negative. So if the index is odd, then you are allowed to have negative number in the radicand. But when the index is even, like this is, then inside has to be positive or 0. If you have negative inside here with the even index, is that possible to have a number, have a real number equal to that? No. Because all the real number, when you square, it will have what? Positive or 0. So, when your index is even, your radicand has to be positive or 0. But when your index is odd, your radicand can be positive or negative. When it is negative, the result has to be negative, right? Now, what is the number? Its cube will be 1,000. 10. Very good. So that's why. Now, how do I simplify? So this is what we just said, right? If it's odd, when you take the nth root of a to the power n, is a. But if it's even, okay, when you take that root, you will take absolute value. So now, let's see this. This is even or odd? Even. So when we take the fourth root of this, it's going to be, look, what is x to the fourth? Taking the fourth root, it will be absolute value of x. Now this is y to the power 20. How do you take the fourth root? Okay, so you see, you need y to the fourth, so that when you take the fourth root, you get y, right? Y to the 20th is going to be power 5 of y to the fourth. So every of this, you get y, and you have 5 of them, and you put the absolute value. Is that clear? Now let's look at this.
Say that again.
Okay, say that again.
Yeah, all over from the beginning, but go really slow.
Go very slow. No problem. I will go very, 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 very slow, okay? By doing this. Coming this. I will do more about, oops, excuse me, here, right? Okay, I'm going to write this as the fourth root, okay? See, you have x to the power, what? 4, and then you have y to the power 4.
Can you blow up the window?
I did? Oh. Okay. And then y to the power 4. And then y to the power 4. And then y to the power 4. Any more? One more, right? Y to the power 4. Okay? We feel happy by looking at this because it's visible. And every y to the fourth, when you take the fourth root, is what? Y. This one, when you take the fourth root, is what? Y. This one, when you take the fourth root, is what? Y. How many? 5 of them. Y times y times 5 times y times y, you get what? Y to the 5th. Okay? So that's why you get that. Do you see that? Okay. A lot of people, they don't need to do this. They understand, oh, 20. I need 4 to get 1 y, right? How many of them? Oh, 20 divided by 4. I have 5 of them. This is power of power, right? Okay. But if you like, at this stage, you are welcome to write this down. So you can do this. So you are clear. You have y times y times y times y times y, which is y to the power.
So when the 4 is on the outside of the radical, it's like you're subtracting the 4 from the 4 inside.
Subtracting what?
Like you're taking the 4 away from the 4 that's inside.
It's the fourth root of
Or so the 4
power 4.
right?
Yeah, it is inverse operator. You take to the power 4, and then you take the fourth root. So you get y. Okay? Is it okay? Yeah.
And if it's a positive integer, your answer is always going to come out in absolute value?
Only if it's even index.
Okay.
For the odd one, look, for the odd one, what happened? I need all your help. If this odd, negative, you will get negative, right? 27 is 3 cubed, so you get 3. 2 to the power 6, so you need 2 to the power 3, and then 2 to the power 3, you have 2 of them. Right? Is that clear to you guys? Do I need to do this again? Yes? It's like this. Do you see that? I need your help. Okay, I really cannot talk too loud. Okay, 27. You know what is 27? 27 is what? 3 cubed. Am I correct? 27. I can make it better. 3 to the power 3. Okay? Now, so, for this 3 to the power 3, you know that you will take a cube root, so you get 3, right? Now, how about this? A cubed, taking the cube root, you will get what? A. And you have another one, right? So you get A squared. Is that okay? Is it crystally clear? Okay. So now let's do more. Sorry. Okay, now how are we going to look at A to the power 1/2? Okay, now, what is 16 to the power 1/2? 16 to the power 1/2. So you will get what? Square root of 16, which is 4. What is W to the power 1/2? It's 4th root of W, right? How about this one? It will be 5th root of 3ABC, right? Okay. Now, let's rewrite them. Okay, can we do all together? Originally, I want you to do by yourself, but let's do together. Can you say out loud, okay? I want you to write this with a rational exponent. Okay. Oh, I will go back. I will go back. Sorry. Here. You probably would ask me, Dr. Chen, I know this. I don't like that. A lot of people don't like this look, you know, just like people feel more comfortable. Sorry? It's ugly, huh? People, when they look at law, people feel more comfortable in exponential. They will try to rewrite the law to exponential. Remember, on the quiz, I asked you, rewrite the log expression as exponential, right? Because people feel more comfortable with exponential. But you now feel comfortable with log now, right? The same way. You feel comfortable with the radical expression. But we are going to say, hey, we would like to write this as exponential expression with rational exponent. You say, Dr. Chen, you have to give me a reason why you want me to do this, right? There must be a purpose. Why we want to use this, not that? Anyone give me a good excuse or reason? Because? Okay. In chapter 1, we review all the rules of exponent. And you all remember A squared times A cubed. Tell me, what is that? A to the 5th, which is you just have 2 plus 3, right? A to the 5th. A squared to the power 3 is what? A to the power 6, right? Because it's A squared, A squared, A squared. So it's A to the power 2 times 3, which is A to the power 6. These are the rules for exponents, right? Integer, 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 integer. So easy to use, am I correct? So we hope we can deal with the radical in such an easy way. Therefore, we say, let's represent those radicals in exponential form. Then we can use this. So now, if you are going to talk about this times cube root of W, oh, how can I do this? Now you say, yeah, not a big deal. Write this as W to the power 1/2, and that is W to the power 1/3. When you multiply with the same base, what do? You add. So it's 1/2 plus 1/3 as your exponent. And you can write it, this is 3 over 6, this is 2 over 6, so it's 5 over 6. Much easier to do this kind of operation. So we do want you to be able to do it. So now let's do it. Examples. Square root of 6x. How do you write the exponential form? It's what? 1/3 of 6x. Can you have your red pen or red marker? Can you put parentheses here? It should be red. Okay? You have to put the whole radicand in whole parentheses. Did I make it clear to you guys?
It's a cube parentheses and within the parentheses.
Yeah, it's the whole radicand.
Yeah.
You take the cube root. Okay, how about this? Then you are going to say, what is a radicand? The radicand is, no, it's a 12c to the third. That is a radicand, right? And then the whole thing, you are going to take what root? 1/5. Are you with me? This is the radicand. The whole thing here is your radicand. Okay? The whole thing here is your radicand. Of course? Understand? Say it again.
So does that become 12c to 3/5?
So now, what do you have? You say this is what? Power of power. So 1/5 times 3. What is 1/5 times 3? It's 3/1 times 1/5. So it's what? 3/5. Does it make sense? That is aha moment. Do you understand this?
Yes.
Okay, I will send you this PowerPoint, but you have to know this is a very, very important example. Okay? Now, next. What about this? This is the whole radicand, which is inside the radicand to the power 1/6. So therefore, you have 2x over y, the whole thing, 5/6. So what did you learn? The denominator 6 here is what? Index, right? The numerator is what? Power. Yes? The 3 is the power. The index is in the denominator, right? The denominator means what? The index. The numerator is what? The power. Is that right? So, look at this. So, tell me, the denominator represents what? I couldn't hear you. The denominator represents? Only 3 people answer. Index. How about the numerator? It's the power. Okay? All right. Now, let's look at the part D. They want you to go back. If I give you this, can you represent this way? Yes? You say yes. The denominator is the index. So you just take the 5th root. Now, look at this. How do you write this? You say the index. Yeah, the denominator is the index, right? And then how about the result? You say, well, the cube root of -64 is what? -4. And you have square. So it's 16. Is that okay? Now, if you are going to have general exponent like this, m over n, then you can do it, say, m times 1 over n, and 1 over n is your what? Index, right? Okay, so let's do the part A. Can you see this, my friend? So this is what? Square root of this, am I correct? And then square root of 16 is what? 4. So it's 4 cubed, it's 64. Okay, how about this? It's the 4th root of w cubed. How about this? Now you have to be very, very, very careful. The denominator is what? 5 is index. So it's the fifth root of the whole thing. Okay? It's a 3abc parentheses square. That means what? 3 squared, a squared, b squared times c squared. Is that right? It's not distributed. It's power of power. Okay? It's just like this. It's power of power. You will say, what is the rule that we use? Say one more time. It's what? Power of power. One more time. Power of power. When you have power of power, what do you translate off? Multiply, right? Power of power. You multiply powers, right? Okay. What about if you have negative exponent? If you have negative exponent, you have to take what? Reciprocal. So it will go from numerator to denominator. Are you with me? What is the half power of is 3? Of 9 is 3. Now how about this one? Can you tell me? You are going to take from denominator to what? Numerator, right? Because you have negative exponent. Then it will become what? 25 over 3 half power. And then, you know, denominator is what? Index. So it's square root of 25 cubed. And square root of 25 is 5. So it's 5 cubed is 125. Is that okay? All right. So now we are going to yeah, I will put it on the canvas. Yes, I will put all of them there. Okay. Okay. Now we are going to, this is something that you love, okay? Remember what I just said. The reason why we write it in exponential form because we are going to use them. We're going to use a rule to simplify. What are they called? Can you read out loud the first sentence? I saw you like nodding the head. So those are called laws of exponents. How many? How many laws of exponents? Not many. Not many. Actually, this is the fundamental one. Okay? The first one you have to remember is, what is this? 1. You are awesome. Yes, it is 1. Okay? Any non-zero number to the power 0, you get 1. Okay? If you have the same base, you add up the exponent. If you have power of power, you multiply the exponent. Does it make sense to you? So let's see, what are those? Okay, back. Do you know this? What does it call? A to the 0th power is 1. What about this? Say out loud. Negative exponent rule. So if you have negative exponent, you will take what? Reciprocal. What is this? Product rule. If you multiply with the same base, you just what? Add exponent. What does it call? Quotient rule. If you divide, but they have the same base, you what? Subtract. What is this? Power rule. You know, a lot of time I told my students to call this power of power rule. Sorry. It's power of power rule, okay? Because it's a power of power. When you have power of power, you multiply. Is that right? Okay? What is next? It's a product to power. If you have a product, A times B raised to R's power, is also power of power. They are all power of power. This is exponent 1, exponent 1. So 1 times r is r, 1 times r is r. Does it make sense? This is also power of power. Quotient to power. Okay, so if you have a quotient, okay, the power of power, so it's r times 1. Here is r times 1. It's also power of power. The last three, I all call them power of power. How about if you have negative exponent? You take what? Say out loud. Reciprocal. Do you see that? Take the reciprocal. So a over b to the power negative r is b over a to the power r. Does it make sense? This is your old friends, right? It just before you use integer, now you use what? Fractions. So can I have you all look at your book? Okay, everybody have a piece of paper out. You have to do some work and you have to turn in. Okay, look at section 6.2. 6.2. 6.2. Do number 9. Do number 9. Number 9.
489.
Page 489. Do number 9. And number 13. Number 9 and number 13 and number 4. It's a good word, yeah. But you need to turn in. Number 9, number 13, and number 14. 9, 13, and 14. What? 6.2. Okay. So this is, okay. So this is an integer case, right? All right. What about this? So you will say this is x, and then 3 minus 7 in the exponent, right? Yes or no? So this is x to the power negative 4, and this is what? X to the power 3. Agree? All right. Now, we would like to, there are several ways that people do this kind of simplification. And I would like to follow what the books did so that you know, when you read it, you feel comfortable. And I can show you the other way that people do. Okay, now, this is a quotient, this is a fraction. Do you see the base x in the numerator and the base x in the denominator? Yes. All right, so for the number, it's 25 divided by 1. So it's what? 25. For the base x, I need your attention because later I won't be able to say it again. So what is the power? 1/2 minus negative 3/4. If you didn't listen to this, you don't know what I meant. Okay. Listen. What did I do here? This is a quotient rule. Okay? So when you have a division, when they have the same base, you just subtract the exponent. You can do, yeah, I will show that too. Yeah, later. All right. Listen. Okay? Yeah. And then how about y? Y will be what? Power 3/4 minus, what is the exponent here if I don't write it? 1. Wait, not yet. That is just inside the parentheses. You have what? Power 1/2. Are you with me? Okay, so let me simplify it a little bit. So what is 25? 25 is 5 squared. Agree? And then x to what power? This is 1/2. So 1/2 is, so let me put it on side. 1/2 minus negative 3/4. That is 2/4 plus 3/4. And that is 5/4. Is that right? Always put that on the side. So you make it very clean. So it's 5/4. Is that okay? How about for y? 3/4 minus 1 is 3/4 minus 4 over 4. So that is negative 1/4. Do I make it clear to you guys? And then the whole thing to the power 1/2. Is that right? Yes or no? Okay, now, this is the power of the whole thing. So I'm going to use power of power, right? So what do you get? You get 5 to what power? 2 times 1/2. What is 2 times 1/2? 1. And then x, 5/4 times 1/2. What is 5/4 times 1/2? It's 5/8. And then y. What is negative 1/4 times 1/2? It's negative 1/8. Do you see that? Okay, it's power of power, right? Okay, now, we would like to have the expression simplified if the exponents are positive. Okay, this exponent is positive. This exponent is positive. Uh-oh, this is not. What do? You will take the reciprocal, so you will go down to the denominator. So you will have 5x to the power 5/8, and then y to the power 1/8. Okay? I'm going to show you some people, they like to do it a little bit differently, and I'll show you how. This is the final answer. Want to get into what? Oh, no, you don't need to. You don't need to. They didn't ask you, you don't need to. Okay? All right, now, someone just suggested, say, Dr. Chen, when I come back to this negative 3/4 exponent, I am thinking, so I'm going to put it side by side. I will write it again, okay? So you see what's going on. So the same problem, okay? Some people say, Dr. Chen, I like to take the reciprocal. I just love to get rid of those negative exponents. So when people see negative exponent, they say, let's take reciprocal right away. Would you like to do that? Some people like to do that. So then you will have y stay, but then x to the negative 3/4 is going to reflect it to, it's going to take the reciprocal and go up to the numerator. So you get what? 25 x to the power 1/2, and then times x to the power 3/4, and then times y to the power 3/4. Because negative 3/4, this is negative exponent. If you want to change it to positive exponent, you need to take reciprocal. Does it make sense to you guys? Now the whole thing, what? To the power 1/2. Now, obviously, you are going to add up these two exponents, right? So you get what? 5 squared times x to the power 1/2 plus 3/4, that is 5/4. Okay? Is that okay, my friend? Oh, 1/2, right. Okay? And now what? And now what? And some people say, you know, Dr. Chen, I like to take care of the power of power first. You know, so some people say, oh, okay, I'm going to do power of power. So I will have 5 to the power 2 times 1/2 will be 5. And then 5/4 times 1/2 will be what? 5/8. And then y to the 3/4 times 1/2 is going to be 3/8, right? Sorry. And then y to the power 1/2. Okay? Is it okay? I'm using power of power, right? Where? 3/4 times 1/2. Okay, is 3/8. Now, this is a time for you to look at the same base. Oh, y, they have the same base. So I'm going to take care of that. So So y to the power 3/8 minus 1/2. But what is 1/2? It's 4/8. So you will get 5 times x to the 5/8 times y to the negative 1/8. You see that? And then it's a negative exponent, so you go down again. Don't you get the same answer? So, what is the conclusion? It depends on the situations, okay? Either way, you are using what law? Law of exponent. Okay, so today's homework, listen carefully. Oh, yeah. I know. I need to prepare you for your midterm, right?
I can tell you right now that nobody's going to finish
At least do no textbook. Yeah, no textbook.
No, textbook is fine. No, MML, it takes too long.
It's too much.
No, MML textbook.
It's too much. It doesn't give me enough time to write
I
everything.
feel like I have no time until you will never finish them, so you just give up.
That's what I do.
It really does get to that point. I'm so behind in my homework.
Really?
Yeah, really. I don't think I've ever really fully completed a homework packet. I have no time. There's just something has to get sacrificed.
Okay, all right. So, my friend, you are all my friends. I'll try to help all of you. 6.1 and 6.2, you feel that you just need the MML? Only?
Just 6.1 though.
Well, okay. Yeah, I mean, the rational expression does take time. I agree. It does take time. Yeah, I totally agree with you.
It has to be like one or the other. It can't be like MML and textbook because there's like 20 problems
I
for
see.
each MML, so that's like
All right. You know what? No, textbook, I only give you like 5 problems.
for each one though, so that makes like 60 problems.
No, but every section, you do need to have some problems that you do then.
That's like a total of like 50 to 60 problems.
Where?
Yeah, because each MML is 20 problems.
We've got all the
I see. All right. Okay, my good friends.
I would normally, I just haven't.
I will do this. Listen, for this chapter 6, okay, for this chapter 6, you do need a lot of practice. Trust me, practice. But we want to go deep, right? We don't want to spread out and get it thin. For chapter 6, for now, chapter 6, I will just go with MML. Would that be better for getting both? Much better? Much better for just MML? You have to write it down as if it's from the... okay. Some people I heard, you like the textbook homework. How many of you like the textbook homework?
I would like it because it's
It's-
problems, that's why.
Yeah, I do.
It's
But the MML positive point is if you don't know,
oh, you know what?
explain how.
Right.
Yeah, it has to be one or the other.
Let me tell you, because MML is going to have everything recorded, right? It does the same thing, okay? The textbook, you don't get the help step by step. But the MML, you do get the help step by step, okay? Right now, I would like to go with the MML so that you get all the supports, okay? The textbook, you can always get it. I'm going to use textbook as examples, quiz problems, for discussion and so forth, for just chapter 6. Because, right now, I want you, to feel good about what you're doing, okay? All right, but get yourself ready for the midterm. I will put everything on Canvas, all right? You will have a take-home quiz as what we discussed earlier, yeah.
I still don't have the other two done.
Oh, you're behind, yeah.
I